Today we're going to cover some examples from exercise 7.2. Okay, we are now on chapter 7.2, 2B textbook of Discovering Mathematics, and this is applications of Pythagoras' theorem. Okay, so first please send your textbook to page 10. Okay, I'll cover question 3. Alright, so first, right, we notice that this is actually a right angle triangle over here. So what would be the distance if she walked to spot B directly from spot O? Okay, so you want the direct line. So basically what we can do is simply apply Pythagoras' theorem. So immediately I write by Pythagoras' theorem. Okay, I will say that OB square is equals to 4.15 square plus 2.8 square. So if I square root both sides, be careful. Okay, when you square root, you have to square root everything. If you do this, you just square root each term. This is wrong. Alright, you should be square rooting the entire thing. So if we square root 4.15 square plus 2.8 square, what we'll get is the OB value of 5.01 km. Still on page 10 of your textbook, we're going on to question 4. So first thing they want us to find is that they want us to find the length of XM. So this being an equilateral triangle, it means that YZ is also 10 cm. Okay, so in this case, for an isosceles triangle, okay, if you draw a perpendicular down, it will divide the base exactly into two equal portions. So therefore ym is 5 and mz is also 5. So let me just write it down. Okay, ym is equals to 5 cm. So once again, we have written this quite a lot of times. Okay, by Pythagoras' theorem, I'll say 10 square is equals to 5 square plus xm square. So xm square is equals to 10 square minus 5 square. So what we get is xm is square root of 10 square minus 5 square equals square root of 75. It gives me 8.66 cm. Remember, this should be given correct to 3 significant figures. So now we want to find the area of triangle XYZ. So area of triangle, if you remember from primary school, is equals to half times base times height. So half times base. The base in this case is here, so we'll use the value 10, okay, times the height. Okay, you may be tempted to use 8.66, but I would suggest you use this form. Square root of 75 is called the surd, S-U-R-D, the surd form. It is the most accurate. So we will put it here as square root of 75. So if you compute the value, what you should get is 43.3 cm square. Still on page 10, we are on question 5. Alright, so now in question 5, they say that a square is cut from a tin plate as shown. The diameter of the tin plate is 20 cm. So the diameter is 20 cm, and this being the center, so this will be 10, this will be 10. Okay, from here to here is 10 cm. This is actually the radius of the circle. It means that from here, the center, to D, it will also be 10. And what does it form? It forms a right angle triangle. So what we have is a right angle triangle that looks like this, 90. This is 10, and this is 10. So I will want to find the length of the side of the square. So okay, I will say let the side be x. So once again, we're writing these words by Pythagoras' theorem. X square is equals to 10 square plus 10 square. X is equal to square root of 200, and we just compute that. What we get is the length of DE is 14.1 cm. Okay, Now, it's quite a short lesson today. We have come to the final example of the day, which can be found on page 11 of your textbook itself. So this is about a wire stretched between two tops. Okay, now simple thing here. First, if you look, this is 13, this is 20 and 13. Hence, if you minus off, this length over here will be equals to 7, not meter, not cm, but 7 meters. Alright, so we get 20 minus 13, so this length here is 7 meters. Then we also know that down here this is 24 meters. So if I just make a rough sketch, okay, of the triangle that we're going to use, it will be 24 and 7. So now we're going to find the length of the wire, and the length of the wire is AB. And once again, we say that by Pythagoras' theorem, AB square is equals to 7 square plus 24 square. Then AB is equals to square root of 7 square plus 24 square. So if you just compute this using your calculator, what you'll get is a very nice number of 25 meters. And that concludes my examples on